Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz and as ever I am the IT Geek. Welcome back to another episode in my SC-100 Microsoft Cybersecurity Architect exam topic series. This is the final topic. We are in the last three videos, it's the final countdown. I always get a sense of, it sounds bad, but I always get a sense of relief when a series is coming to an end, just because it's, a lot of the time my series are quite long, especially the exam topic series. It's a lot of videos. It's a lot of time spent, and it's relief and a feeling of accomplishment as well because sticking with so many, like a whole series with 15 topics. This one, for example, it's a big exam, and I'm proud. I'm happy that I've seen it through because it's very easy to just stop halfway and go do some other content. But hopefully, this is going to help you guys and you people in your exam preparation. So without further ado, let's get started with this new topic. So as I mentioned, this is a Microsoft Cybersecurity Architect exam topic series. We're on topic 15, part 1. There's going to be 3 parts. And we're going to, in some episodes, we're going to have a demo. And I think in others we might not. So today, actually, we're going to focus. So this topic is actually designing solutions for network security. So we'll talk about designing solutions for network segmentation, and then we'll talk about designing solutions for traffic filtering and NSGs. Or network security groups specifically. So let's start off by talking about designing solutions for network segmentation. So when you operate on Azure, you have many segmentation options. You can segment via subscription. So this is a high-level construct essentially, and it provides platform-powered sort of separation between entities. And it's intended to carve out boundaries between large organizations within a company and communication between resources in different subscriptions. And this needs to be explicitly provisioned as well. We then have what's called virtual networks or vNets. And these are created within a subscription in a private address space. And they provide network layer containment of resources with no sort of traffic allowed by sort of default between any two virtual networks. Unlike subscriptions, any communication between virtual networks need to be explicitly provisioned. So I suppose in old money or in sort of on premises, this would be a network. So an office network. See it as an office space. Within your London office or within your Leeds office or Manchester office. You may have you'll have a network and everyone will be on that network, and then you can segment it another layer. And that brings me on to network security groups. This is another way of segmenting or another element of segmentation. So this is an access control mechanism for controlling traffic between resources within a virtual network and also external networks as well. And this includes the internet or other virtual networks. NSGs and network security groups can take your segmentation strategy to a more granular level. And this is by creating those perimeters for a subnet or a VM or a group of VMs. Now, again, in old money, let's say in on-premises terms, think of an NSG. It's like a little mini firewall essentially, and your subnets are your VLANs. So your subnet's like a VLAN, and your NSG is like your inbound, outbound sort of security for those VLANs. We then have application security groups or ASGs. So these are similar to NSGs but a reference with an application context. And it allows a group of set of VMs under an application tag and to define traffic rules that are then applied to each of those underlying VMs. And then we have an Azure firewall. So this is a cloud-native stateful firewall as a service, and this can be deployed in your vNet or in an Azure Virtual WAN hub deployment for sort of filtering traffic flow between cloud resources, the internet, and sort of on premises as well. And you create rules and policies using the Azure Firewall, or you can use Azure Firewall Manager. And these are going to like to specify, allow, and deny traffic using layer 3 or layer 7 controls. And you can also filter traffic going to the internet using both Azure Firewall and third parties by directing some or all of that traffic through third-party security providers for advanced filtering or user protection. So those are some of the sort of segmentation elements we've got in cloud, specifically Microsoft Cloud. So we'll talk about some of these patterns now. The first pattern that we mentioned was after subscription, I suppose, was this is more network focused. Subscription is not really network layer. It's a single VNet. So this is one of the segmentation patterns, and similar common. These are some common patterns for segregating workload in Azure from a network perspective, as I mentioned. And each of these patterns are going to provide like different type of isolation and connectivity. So with a VNet, all the components of the workload reside in a single virtual network. And this pattern is appropriate if you're operating in a single region because the VNet cannot span multiple regions. You can have separate VNets in separate regions, but you can't span that. Common ways of securing segments such as subnets or application groups are by using NSGs and ASGs, as we mentioned already. You can also use network virtualized appliances or NVAs from Azure Marketplace or an Azure firewall to enforce and secure the segmentation. As you can see in this image, subnet 1 has that sort of database workload, whereas subnet 2 has that sort of web workload. And you can configure NSGs that allow subnet 1 to only communicate with subnet 2 and can only communicate with the internet. So pattern 2 is multiple virtual networks communicating through a peering. So consider a use case essentially where you have multiple workloads that are placed in separate subnets. You can place controls that are going to allow you one workload to communicate to the back end for another workload. So pattern 2, as I mentioned, as we see, is multiple VNets in communicating through peering. So these resources all spread or replicated in multiple virtual networks. Can we see we've got two regions. The VNets can communicate through what's called peering, and that's essentially making a connection between two virtual networks. That's simple. This pattern is appropriate when you need to group applications into sort of separate virtual networks, or you need multiple Azure regions. One benefit of this is the built-in segmentation because you have to explicitly peer one virtual network to that other one, and virtual network peering is not sort of transitive. So you can further segment with a virtual network by using NSGs and ASGs as we saw in pattern 1. So let's talk about pattern 3 now. Let's move on to pattern 3, the last pattern I want to discuss. So this is multiple virtual networks in a hub and spoke model. So if you're familiar with the cloud adoption framework or well-architected framework, CAF and WAF, you'll know of the hub and spoke model. Going into any detail, that hub and spoke model is outside the sort of scope of this topic and this series. But if you are, it's an architect exam, right? So if you've done, you should have really done architecture already for a certain level in cloud. So you should really be familiar with CAF and WAF already and the hub and spoke model. So in this pattern, a VNet is designated as a hub in a given region for all of the virtual networks. So that's your center, basically. You can see that in the diagram. And then the other virtual networks are known as spokes. So think of a bicycle tire, like a bike tire. You have spokes coming out from the center. The hub and its spokes are connected through, again, network peering. All traffic has to pass through the hub, and that acts as like a gateway to the other hubs in different regions. And in this part, the security controls are set up so that they get to segment and govern the traffic in between other VNets in a sort of scalable way. One of the benefits of this pattern, as your network topology grows, the security posture overhead does not grow, except when you expand to new regions, obviously. And with this, as you can see in the diagram, no two spokes can directly communicate. They're not peered with each other. They're all peered with the hub, and then the hub will allow or deny traffic to the different VNets or region, depending on what you've configured, essentially. So just do a bit of a comparison before we move on to the next subtopic within this video. So if we look at considerations from a connectivity and routing perspective, how does each pattern communicate to each other? Within a pattern 1, system routing provides that default connectivity to any sort of workload, any subnet. With pattern 2 is the same as pattern 1, but with pattern 3, there's no default connectivity between the spoke networks, as I mentioned. A layer 3 router, such as an Azure firewall in the hub, is required to enable that connectivity. We consider network level traffic filtering. In pattern 1, traffic is allowed by default, so you use NSGs and ASGs to filter traffic. And pattern 2 is the same as pattern 1 in that sense. But with pattern 3, traffic between those spoke virtual networks is denied by default. As I mentioned earlier to that diagram, then you open those selected paths to allow traffic through Azure firewall configuration or a third-party firewall, or NVA maybe. We consider centralized logging, NSG, ASG logs for the virtual network for pattern 1. For pattern 2, you aggregate NSG, ASG logs across all your virtual networks. And with pattern 3, the firewall logs are accepted or denied traffic sent through the hub. You can view logs in Azure Monitor. Then we'll consider about unintended open public endpoints. With pattern 1, DevOps can accidentally open a public endpoint through the incorrect NSG or ASG rules, and pattern 2 is the same as pattern 1 in that sense. But for that consideration in pattern 3, accidentally open public endpoints in a spoke will not enable access because the return packet will get dropped through stateful firewall, which is asymmetric routing essentially. Finally, the consideration of application level protection. So we've got, again, pattern 1 and pattern 2, we have NSG and ASG, and they provide network layer support only. But with pattern 3, we've got the Azure firewall, or a firewall that supports FQDN, or fully qualified domain name filtering, for HTTP or HTTPS and MS SQL for outbound traffic and across that virtual network. Okay, so let's jump into the final topic before we go into the demo. So let's talk about designing solutions for traffic filtering with NSGs, and we're going to look at NSGs in the demo as well. So you can use an Azure Network Security Group to filter network traffic between Azure resources in an Azure virtual network. A security group contains security rules that allow or deny inbound traffic, network traffic, or outbound network traffic from several types of Azure resources. For each rule, you can specify source and destination, port, and protocol. First, let's talk a little bit about security rules. So a network security group contains 0 or as many rules as desired within the Azure subscription limits, obviously. And each rule specifies multiple different properties, including a name, which is a lot of a unique name within that network security group. The priority, so this is a number between 100 and 4096, and then rules are processed in priority order, so with lower numbers processed before the higher numbers, because lower numbers have a higher priority. And then once traffic matches a rule, processing is then going to stop, and as a result, any rules that exist with lower priorities that have the same attributes as rules and the higher priorities are not processed. We then have the information of source or destination, so this is any or individual IP address, classless inter-domain routing or CEDR block, example 10.0.0.0/24, for example, or service target application security group. So if you specify an address for an Azure resource, specify the private IP address assigned to that resource. Same with network security groups as well. They're processed after Azure translates the public IP address to a private IP address for inbound traffic, and before Azure translates a private IP address to a public IP address for outbound traffic. We then need protocols, so TCP, UDP, ICMP, etc., etc. The port range, you can specify an individual or a range of ports. Example, you could specify just port 80 or port 10,000 to 10,005. Then have directions, so this is whether the rule applies inbound or outbound. And finally, are you going to allow or deny that traffic? Okay, so we're now going to jump into the Azure portal, and we're actually going to just have a look at NSGs and then have a look at peering as well. So let's jump into the demo. So we're in my I Am IT Geek demo portal. Let's just go to network security groups first. Network security groups. Let's have a look at, so I've got one here. I just want to show you an existing one and how they look. The important thing with NSGs is the inbound and outbound security rules, right? You have the general, put it in a resource group, put it in a subscription, yada, yada, yada sort of thing. But the most important thing is that the inbound security rules. So the default, so when you first create an NSG, it has it has six rules, 3 outbound, 3 inbound. They're the exact same rules essentially, just reversed. So you have the first allow vNet inbound, which is got that one of the highest. It's got a high priority of 65,000, and that's any port, any protocol, but the source is the virtual network and the destination is the virtual network. So that's basically any virtual network inbound, allowing inbound traffic to vNet. And then you have the equivalent outbound as well with the same priority. But then we have allow Azure load balance. So this is for load balancing inbound as well. So again, the source is Azure load balancer, but everything else is pretty much any. Finally, the highest priority is the deny all inbound. This is basically a deny rule. So you need to make sure any rules that you put have a higher priority than this. Otherwise, it will be blocked. And this is essentially an any rule inbound, and you have the same outbound. So when you can create these inbound and outbound security rules, you go to settings on the NSG, and you simply go to add. And here you can again specify the source, as I mentioned in the presentation slides, It can be IP address, can be your IP address, service tag, application group, or you can leave it any. Same with, so you can here with the source ports as well. You can provide a single port, so with port 80 as the source port, or star is just any. And then destination, is it IP address, is it service tag, is it application group. Again, you can have a custom service as well if you want. And then again, put the destination port, so it's going to be 8080 or 80 or whatever. Then the protocols we mentioned, we've got any TCP, UDP, and ICMP, and then whether or not we're going to allow it or deny it. And then make sure you give it a priority. So this is very important because if you've ever worked with firewalls, again in on-premises world, you can have clashes with inbound outbound rules, or sometimes just inbound rules or outbound rules. So it's important to give your rules the relevant priority, so we don't clash with other rules. And like I said, the deny rule, so don't give this a higher number than 65,500, because then this will just get denied, because that deny rule will be processed first. And then give it an appropriate name, and make sure this name is something that you're gonna, it's gonna, when you read it, it'll be like, oh, okay, I know what that is. And then obviously a description as well that's kind of clear for anyone else who might be looking at it. And the other thing I just want to look at is virtual network peering. So again, let's go to virtual networks. I'm just going to pick one at random. I'll pick my DevBox virtual network here. And in settings, you have pairings. So this is where you can essentially, I've got to get an existing one set up with one of my other virtual networks. I can't remember which one. Yeah, with vNet 1, that's fine. And here again, this is just doing connectivity. So basically connecting to offices. So I suppose again in on-premises it might be a site-to-site VPN, or if you've got two virtual networks in the same building, you'll have some sort of connector, a cable connected maybe, or a central fiber or something like that. So try and envisage that when you're thinking about peering. Again, when you add peering, when you want to add peering, you give it a name. Make sure you select the subnet and which subscription and which virtual network you want to pair it with, and then you basically reverse and just select. Do you want to allow peering network to access DevBox? And obviously you want to tick that. Do you want to allow it to network to receive the forwarded traffic, which I normally leave unticked? Do you want to allow gateway or root server in the paired network to be able to send traffic? Do you want to enable network to use this virtual network's remote gateway or not? I'll leave that empty, or don't tick that. Give the local virtual network, so this is where you're pairing it with. So give your local peering network link a name. And again, the same options there, and then you can add that, and then what you essentially get is this. So it tells you if it's, you get, so this is what I selected with this pairing that I did a while ago. But here essentially is what you see. So you've got the name of it, DevBox pairing, fully synchronized, pairing states connected, and the virtual network name as well there. But so virtual network gateway is disabled. Wrong button, my apologies. Try to give an overview of NSGs and network pairing, because we kind of discussed it and give you the option to visualize it. Obviously, these labs that I'm doing are not part of the SC-100 exam. It's an architecture exam, so there's case studies involved. So in the GitHub repository, I've put a link in the description. There is a link to those case studies. I very strongly suggest you review those. And also there's a link to measure up discounted practice exam. And again, I recommend doing practice exams. They're very, very useful, and they help with your preparation. And they're legitimate practice exams, by the way. Measure Up are one of the official partners of Microsoft. So all above board. And also link to my socials as well. Reach out to me, connect with me, ask me any questions, or leave a comment. If you're not subscribed, why not? You've probably seen on my social media, I am trying to push for 20k. I'm almost at 19, so I'm almost there. I want to push there before the end of the year, so thank you for your support. So continue to watch. We're coming to the end of the series, so until next time, thank you and goodbye.